Excellent. So welcome everybody. This is the July meeting of the Drone Research for Advancing Community Healthcare and Medicines Access Network, or DRACHMA, as we like to call it. So we've got two fantastic speakers today. We've got Gabriella from VillageReach, who is going to be talking about the curation of the data, and also the translation and dissemination of that data as well. And also we've got from kind of my home team, as Tortoise has just come in, Vasilis from the Department of Engineering, and this works very well. Two sort of data-driven pieces, but on two ends of the sort of spectra. Something that's happening now, recording medical deliveries that are actually happening now and being very, very successful, and then hopefully some things for the future, which is very good. So both speakers, if you can keep it to about 20-25 minutes, so it gives us some time to talk. The usual rules apply, is that I'm going to have the chat box open, and as we go along, if you think of a cracking question, put that in the chat box. If we've got lots of time and only a few questions, then I will just ask you to pose those to the speakers at the end. If we have a lot of questions, then perhaps if the audience votes which one they think has the priority or is most important, then I can get to those ones first. But I'm now going to stop sharing my screen, and that should come back. So Gabriella, if you could just give us a minute or two on who are you, the fantastic work you do, and then your presentation. It'd be great.
Of course, yeah. Thanks for having me today, and good afternoon or good morning, everyone. So I'm Gabriella Ailstock. I play a little bit of two roles. So my first role and my primary role is that I work for VillageReach, and VillageReach is an international health organization who our mission is to transform healthcare delivery to reach everyone. And a large part of our work there is actually working to integrate drones into health systems where we work. And so on my other flip side, though, is that I also am the coordinator for the UAV for Payload Delivery Working Group, and UPDWG, as we call it. So I'll use that acronym. I guess we like weird acronyms in this space for our working groups. UPDWG is a global network of stakeholders, and I'll get into that in a little bit. But our goal is to advance and accelerate the introduction of drones into health systems around the world. So those are my two roles that I play. But today I'm going to have my UPDWG hat on a little bit more today. And I will talk about the curation and dissemination of medical drone delivery data and evidence. So thanks so much for having me. So first, I will get a little bit more into who UPDWG is. So like I said, we're a global network of stakeholders. We have over 350 members now, and all of our members are interested in using drones in health systems. Our goal is to provide our members with a venue to share information, experiences, and expertise to accelerate that introduction of drones into health systems around the world. VillageReach and some other partners started this working group in 2016, and the community has grown quite rapidly since then. And so what we really do is that we focus on knowledge sharing and facilitating that knowledge sharing through webinars, our newsletter, and other events and resources. We also do a lot of partner coordination, connecting our members with other members and seeing how we can advance all of their projects. We also have a very large resource hub that is growing that I'll get to a little bit at the end of our presentation here and tell you a little bit about some of those resources. And then finally, one of our big projects from this last year was the creation of a repository to start collecting data and evidence on medical drone deliveries, which is called the Medical Drone Delivery Database, which I'm here to talk with you more about today. So as many of you probably know, the health and development sector is really the global pace setter when it comes to using delivery drones. We've seen tremendous progress in BVLOS operations through these early adopters like Zipline, Matternets, some others in Malawi like Swoop Aero, and places like Switzerland and Rwanda. But despite all of this progress, very little has been publicly shared on the efficacy of these large and small scale drone delivery operations around the globe. And the sector has really been looking at these early adopters to learn from their experiences, but the lack of transparency around the success and the failures and the challenges has really hindered our ability to learn from that experience and grow as a sector. And on top of that, very little has been shared on the impact of this technology on supply chains and health outcomes in comparison to the status quo or ground transportation. So not surprisingly, a lot of funders, healthcare providers, and governments and others in the sector have been reluctant to start operations without this data and without this evidence that we actually see that drones have a chance to have an impact somewhere. So in response to this, with funding from the Interagency Supply Group, UAS coordinating body, and in partnership with VillageReach, my other hat, we created 2 tools. The first is called the Drone Evidence Generation Toolkit, which is a guidance document that helps people understand how to collect and standardize data collection around medical drone delivery. And the other is the Medical Drone Delivery Database, which consolidates that evidence into a publicly accessible and free to access platform to disseminate that information. And our end vision with these 2 solutions is that stakeholders do have that evidence so that they can start making more decisions about when, where, why, and how to integrate drones into health systems. So we really see these 2 tools as complementary to work hand in hand to get to that end goal of having more data to make decisions. So we like to also think of them as a little bit cyclical with each other. So first, we have the evidence generation toolkit that provides guidance and tools and processes and standards to help implementers collect the right type and quality of data and help them evaluate their work. We then see that work gets submitted to the Medical Drone Delivery Database so that it's publicly disseminated, so it goes further than just those implementers. We then see that evidence consolidated in the database that informs future programs and future progress in the medical drone delivery sector, which then comes back and helps inform updates to the toolkit and seeing how we can utilize that experience that's happening to advance how we think about evidence collection and evidence and really evaluations of our work. So we see that both of these tools, the evidence generation toolkit and the medical drone delivery database, really have different value for different types of stakeholders. So for governments like the NHS or healthcare providers, the MD3 and the EGT can help understand what drones are being used for, where they're being used, what their proven capabilities are, what their limitations are, and in addition, the potential benefits that they could offer so that they can make strategic decisions about when to integrate drones into their health systems or their work. For funders, it can help contextualize the results and the work that their grantees are doing and helps them guide future funding decisions and improve the success and scalability of future operations that they might fund. For regulators, both either on the health side of the regulators or on the aviation side of regulators, we believe that these tools can give them insight into the efficacy of drone operations around the world so that it can help inform future operations and future regulations in their countries or their environments. And finally, for the drone operators, the drone companies, or the implementers of these drone technologies, they can promote their work and their results through this database so they can find future clients or future collaborators, and they can also learn from other work that's been happening around the world to apply to their own operations. So before I get into what's actually in these tools, I want to level set a little bit with some terms that you'll be hearing from me. So both of these tools, the data is categorized by 4 different phases of work. And these 4 phases are typically kind of an agreed upon way for us to determine the maturity of drone operations in the global health sector. And so I typically work in the global health sector, working primarily in sub-Saharan Africa and other low and middle income countries. But I also think that these phases can be applied anywhere in the world and really are a good kind of standard to help measure how mature your operations are and where they need to grow to. So phase 0, as we call really the technology demonstration phase. So the purpose of that phase is really just proving that the technology works, that it can fly, it can carry the required amount of payload safely. And that's typically standalone flights or demonstration flights, and it's not really associated with kind of bigger projects or bigger advocacy to utilize those drones. Phase 1, safety and feasibility testing, is when implementers demonstrate the feasibility of potential medical drone operations through safe, repeated drone deliveries carrying the required payload at a small scale over maybe the course of days or weeks or a few months. That's always in that geography where you actually want those drones to be used. That's quite important because, as we know, a lot of drones are not manufactured or built where the drones actually need to be used, and they're quite sensitive pieces of technology in robotics. So the climatology can really affect how they operate. In phase 2, we call that establishing operations, where you're actually establishing a routine drone delivery system, and it's operated for several months in order to generate evidence on the effectiveness and the efficiency of those medical drone deliveries in comparison to the ground-based transport or whatever you had before, whatever your previous system was. And finally, phase 3, we call scaling for impact. And so that's where we see if in a phase 2 operation, you have some data and some evidence that drones are effective and efficient, then you can scale those up to start maximizing your impact in a larger geography, a larger scope. And you also have the support of sustainable business models to accompany those longer term flights that are actually being implemented at that phase. All right, so now I'm going to get into a little bit more of the meat of what these tools are. So the first, the Drone Evidence Generation Toolkit. This is a PDF document that was developed by VillageReach, and it's available here on our UpDog website. And so you'll have these links when we're done. We can probably send the tools around as well. And so this toolkit is an interactive toolkit, like I said, to help drone implementers collect the data required to evaluate the success of their operations. So this toolkit contains resources that are tailored to each of those phases that I just talked about. So the toolkit right now has descriptions of each of those implementation phases. It has logical frameworks, which are suggested results for each phase of operations, what they should aim to do, and illustrative activities that help reach those results. It has high-level evaluation questions to help you guide what kind of data needs to be collected and what criteria to consider before you move to the next phase. It also has means of measurements and indicators that you can actually implement those indicators and how you measure those indicators so that you can measure the results. And that links very closely to the sample data collection tools that actually give you tools that you can start measuring those indicators. And finally, we have case studies, which are descriptions from other implementing organizations on how they utilize the toolkit and how it's been applied to their operations. So right now, we only have all of the tools for phase 1 operations because really that's where most of our sector has been so far. We haven't had a lot of phase 2 or phase 3 operations, but we've started in the last year or two to have more of those. We've been able to learn and see how they're collecting data. And so in August, hopefully, fingers crossed, those new tools for phase 2 and phase 3 will be released in a new version of the toolkit. And so next, I'm going to go into the medical drone delivery database. So like I said, the medical drone delivery database is a user-generated database that consolidates evidence from drone implementations across the world into a free-to-access platform. And this is an online and an Excel database that is located on updog.org, which I will actually switch over my screen so that we can go to the website and I can show you what that looks like right there. Let me just get my other screen up. Okay, let me know if you can see my Google
looks
now.
Fantastic. Yep, looks fantastic.
Awesome. Great. So our UpDog website is just updwg.org. And when you come to the website, you can either go to the MD3 up here in the navigation bar, or you have this nice button down here that will navigate you there as well. So kind of the opening of the MD3 is really this interactive map where you see all of these different pins dropped around the world where we have documented data and users have actually submitted their own data from their drone deliveries. So if I just go to the UK, you can see we have 3 projects that have been submitted already, and I'm hoping maybe after this call we can get some more in here if any of you have projects that aren't in the database. And we've got some filters here, so you can filter by country, by year, by status, if the project's ongoing or if it's completed, and then also by phase of work. So the different type of data that we're collecting is slightly different for those phases of work. So I'll actually dive into 2 different phases. I will show you a phase 1, and then I will also show you a phase 2, so that we can show you some of the slight differences and some of the slight nuances between those phases. So if you click on any of these, you can open up in a new tab the actual data that we are collecting. So here, this is actually one of my projects in Democratic Republic of Congo that VillageReach works on. And so this was a phase 1 project. So you see we collect some just kind of basic information about the project, the country, the year, the contact organization. And then we really go into what kind of evidence was generated under this project and what kind of drone technology was used. So I'll start with the drone technology. So we have the supplier, the model, the method, propulsion, electric motor, gas-powered motor, hybrid motor, and then also some of the capabilities of the drone, and not what it has achieved in that geography, but what this drone, this platform could achieve. So that would be around payload, the volume and the weight, maximum flight time with that full payload, what kind of data links that the technology uses, what kind of delivery method, what kind of role it plays. So does it do delivery and collection, only delivery? Some others could be like, does it do imagery? And then if major repairs are possible in where the drone is actually operating. And then on the actual evidence that was generated, we kind of split it up into a couple of different categories. So the first category is really around the flight data. And so we have the total number of successful flights, the maximum payload, distance, and speed that was also achieved in this geography. And so you'll see that these can be a little bit different, where what are the capabilities versus what was actually achieved in this country of operation. Next, we have some data around regulations and flight permissions. So the type of flight permissions that were secured, VLOS or BVLOS, duration of flight permissions, location of flight permissions. Was it just in a single location or was it broad geographic permission? And then we also have the level of stakeholder engagement, which is quite important to document and to help disseminate that increased stakeholder engagement is needed. So we either talk about engaging just the regulatory bodies, engaging stakeholders at the takeoffs and landing sites. So that might be like the health system, the health workers, the doctors, the nurses, whoever's interacting with the drone. Or if they did a large community outreach campaign targeting the broader community in the areas. And then the next one that is really kind of the meat of where a lot of the richness of this data comes from is around what kind of results were measured from these flights. So we suggest that you look at things like transportation time, product quality, cost, health worker impact, environmental impact, or kind of other impacts that you might measure, such as impacts to the economic impacts or impacts to the broader community. And then based on what results were measured, we also have references to those findings. So reports or webinars or presentations that can provide some more context and some more quality behind these indicators here. And then we also have any related project phases, if this moved on to next phases of work or previous phases of work in that linear kind of progression. And then finally, just some simple kind of implementation details. So what the status of the project is, who the contact person is with their email address, who the partners were, what kind of payload was carried, where this was actually happening, and then who funded this work. So this is the kind of data that we're looking to collect in the database and to share for a phase 0 or a phase 1 implementation. And then I will switch over to a phase 2 implementation and share just some of the nuances between that data and where, when you're getting to a more mature operation, what you should be looking at. So a lot of this is the same, especially around the drone technology. Nothing has changed there. But on the type of evidence that you're collecting, we have a couple of key differences. So first of all, the total number of successful flights here, we're really asking, and it doesn't actually say this, but if you go into the Excel version of the database, it has a little bit more context behind this. We're asking about operational flights, like how many product deliveries did you actually do versus how many test flights did you do? You know, some of the numbers can be very conflated if you're doing a lot of test flights, but really when you get to these more mature operations, those test flights don't matter from a health or supply chain impact side of things. They definitely matter from a technology side or maybe an aviation side for regulators, but from the health side, not as much at that phase. We also, instead of asking about the maximum payload carried, the maximum flight speed, the maximum distance achieved, we're looking at averages here. So just a very slight nuance as well there. We also look at the number of months of sustained flights. So how long was your operation going without any pauses in between those flights? So pauses might be for technical issues, adverse events, regulations, if you couldn't get additional regulatory approval or funding ran out or something like that. And then also looking at the average number of flights carrying payload per month, which can also really help you understand what the scope of the operations were and how routine those operations were actually happening over those number of months. And then for the results measured, we have a couple of different results that we look at on a phase 2 or phase 3. So we look at operational costs. So that's really trying to figure out how we can get more data around how much it costs to run a drone delivery network, which is really limited right now. We look at supply chain performance. We look at operations or financing models, and then health outcomes or impact. So those are the only differences between the phase 0 or 1 or phase 2 or phase 3, but hope that gives you a little bit of a taste of kind of what those differences between the maturity is. And in our evidence generation toolkit, there's a lot more details that kind of goes into why those differences are there. So let me switch back to my other presentation now. And let me make this a full screen. All right. So just quickly, let me give you a little bit of context about what all data we have. So we have 44 entries in the database, and we have documented nearly 44,000 one-way flights from those 44 entries, which I think is really impressive to kind of see that number and see, wow, there's actually a lot of people doing live medical deliveries around the world right now. Around 37% of this data is from East Africa, but the Europe part of this data is growing pretty significantly. I think when I first started the database, we had like 10% of the entries were in Europe, and that's jumped up quite a lot in the last year, which is great to see. And then one other thing that I just want to point out here, since I'm short on time, is around how many BVLOS flights are actually happening. So 89% of the projects are operating under BVLOS, which I think is really great for the aviation regulators in the industry to see and kind of give them some confidence in these numbers as well. And then also on the data completeness, we have some 64% data completeness, and I'm going to get into that a little bit more of what that means on the next slide. So just kind of wrapping up with some of our successes and challenges. So our biggest challenge so far has really been around obtaining that data. I've had some feedback that initially, when drone providers or implementers look at our data collection form, it can be quite overwhelming to them, the amount of data we're looking to collect. But I kind of countered that with having a short kind of call with them where I collect the data instead of having them fill out the Excel form themselves. And they're like, oh yeah, actually, this is all data that I know off the top of my head. Like, it looks overwhelming, but actually once you fill it out and once you think about what kind of data this is, it's not very hard to fill out that data. So that's kind of a nice thing, but need to potentially think of other ways to make that data collection process a little easier for them and a little less overwhelming. And one big challenge has been data sharing agreements, or what some drone providers perceive as IP in this data, which I don't totally agree with that, but might be interested if there are any drone providers on the phone. Simply can't put them in because they will absolutely not share how many flights they've completed. And really for us, that's the #1 piece of data that we need from them, because if you don't say how many flights you've done, all of the rest of this is pretty meaningless, and it really doesn't add to the richness of that data. One thing we're going to do to change that, which is going to be a new thing very soon, is that we're actually going to start collecting flights without, or entries without data, and just kind of having a shell there with kind of like on Yelp or something with a button that says claim this data, so that we can start documenting some of the other projects that we know are happening around the world, but we just haven't been able to access that data. So it'll just be quite simple and say where, when, who type of thing without any of the flight data or kind of evidence generated behind them, but just to kind of give a better idea about what's going on around the world. And then, like I mentioned, around the data quality and richness, we have really good data quality, I think, around flight performance. But what's really not good is around the supply chain data, the cost, the health impact, a lot of those measurable results. Not a lot of people are collecting that type of data or sharing that type of data. And so without that, really the context behind all of those flights, all of that performance, everything in the database, it really gets lost if you can't dive into the details. And so that's kind of where the evidence generation toolkit really comes hand in hand with the medical drone delivery database, so that we can start encouraging others and providing them tools to collect that more rich data to provide that context. And then it is 100% an honor system for reporting, and I acknowledge that is a limitation of the database. We have not seen it as our responsibility to be the police of what you're doing and what kind of data you share, and what you claim. But maybe that needs to change in the future. Might be interested to hear your opinions on that. And then finally, on the use and visibility, we've had really good feedback and perception from the global Drones for Health community on the use of the database and how helpful it is. We've had over 2,000 page views in the year that we've launched the database, and it really is always the #1 page that is viewed on our website and our analytics, so drives a lot of traffic to the website as well. And so just wrapping up almost here, some calls to action for you all. If you are doing a drone delivery project in the medical field, or not in the medical field, I still think these tools can be helpful to you. Please utilize this EGT to inform your evaluation design, what data you're collecting, and provide us your feedback on it. And then submit your data, obviously. And the real other one is incentivizing others to collect and share more and better quality data as well by sharing these tools. Trying to, if you're a funder, requiring your grantees to submit their data to the toolkit and requiring your grantees to utilize these tools to inform the evaluation design. If you're procuring drone services, write it in your contract for your drone provider that you're going to share this data and that they can't limit you by their data sharing agreements to be able to share that data. Or if you're a researcher, encourage others to use these standardized methods and tools and then contribute back to them as well. So one more plug that I mentioned at the beginning was our resource library on updog.org. So I just wanted to share this with you all so that you know that it's there. We have over 100 resources in this library, including journal articles, white and gray lit, lots of tools, which I think are really helpful, past webinars that we've held, and much, much more. So I encourage you to check out this resource library if you're interested in more of the evidence that's out there and more of the context behind the evidence. Or if you're putting out papers and publications, please send them to me, and I'm happy to put them in the resource library. And finally, if you want to join our working group, we also hold quarterly webinars. We have a monthly newsletter where I send out updates about the MD3, what new data is in there, and kind of news in the Drones for Health space. The working group is free to join. We encourage all of you to join if you'd like, and you can do so on our website. And that is it for me. Thanks, everyone.
Fantastic, Gabriella. Now, we're a little bit short of time, but there's some really good questions that are coming in, and I'm going to do these back to front because I noticed I'm going for the ones that have been voted the most. So a brilliant question from Andy. How do you prevent inflation of the data against reality to expectation? We're thinking about Audi and carbon emissions, that kind of thing.
Yeah. I think it's really difficult to be able to do that, quite honestly. What I do to validate the data is I do try to look at any public available sources where they might have been able to confirm or deny those. But again, if it's a drone company just putting out a press release, I have no control over them being able to conflate that data. I have been pretty good at being able to weed through some of the conflation and kind of catch some of the drone providers doing that as well and kind of reeling them back in. But it takes a lot of one-on-one conversation to be able to do that, which is a real hard part about this.
Yeah, I can imagine. One from Annalisa here. What about the USA? Any inputs from America?
Yeah, not many, to be perfectly honest. I've had a little bit of trouble locking down some of the people that are who I know are doing flights there, but we did just have one by some folks called Vayu who've just done some phase 0 demonstration flights, but they're pretty impressive. They were over 300 kilometers that they traveled on in one flight. So hopefully getting some more from the States coming in, but I know there is a lot in the States going on still.
Yeah, I think this is a tremendous resource for people designing the next stage of drones, seeing the number of flights. The thing that I've picked up is the massive things you're transporting seems to be a lot less than the kind of labeled capacity. Is that true for many of the flights?
Yeah, I would say so. From my experience working with drone providers, volume is a bigger limitation than payload capacity for weight. And so you do see a decreased weight on a lot of them because the volume is getting filled up before you can actually meet those kilos.
It's the packaging and all that kind. Yeah.
Mm-hmm.
Very last question then from Deirdre about regulation and social acceptance. How do you think your tools are going to sort of break down some of those barriers?
Yeah, I think on the regulation side, I gave a webinar on this to ICAO, which was really great. And they were really interested in seeing this, which I think is wonderful. And from them, I heard that just having regulators see the sheer number of flights that are happening in these other parts of the world, especially from high income countries, when they see the number of flights that are coming out from Rwanda and Ghana and Zipline, it really impresses them and blows them away and kind of can give them a little bit more realization that this is happening. This isn't just in our dreams. This isn't just in the news. Other people are actually doing this. And so we could make this happen as well, too. So I think from the regulator side, that's one really important thing. And then from the community acceptance side, I think that this can also provide a little bit of social pressure to people, which I think is kind of like an underhanded a way to kind of increase that. When you're looking and saying, if we're saying the gold standard is to do community wide stakeholder engagement and wide community perceptions and community sensitization in places, and we have tools to help you do that in the evidence generation toolkit. If you're looking at your implementations stacked up against others and you're like, oh gosh, we aren't doing that and everybody else is, I think that social pressure can help move that along.
Yeah, really. Yeah, I can absolutely relate to that because quite a lot of these projects are being stopped at that point kind of thing. Cool.
Yeah.
I would love to carry on discussing, but we've got Vasilis who's going to be talking about small cell-based stations. So Vasilis, can
you... Okay, just managed to unmute. Okay, thank
you. Brilliant. And I'm going to mute myself and
Okay, let me try to share. Unfortunately, I will not be visible because I'm running this now on my browser, so it's not a standalone now app. So when you share, you disappear somehow. So
that's fine. Really, we can see you again at the end.
Okay, thank you. So I will keep it short. I think like a few minutes presentation about, as you said, the title. So I'm Vassilis Derekos. I'm from the Center for Telecom Research at Department of Engineering at King's College London. Thank you, Paul, for the invitation. Thank you so much. When I saw the email and I saw the title, I said, oh, that should be some economic discussion about drachma. We're going, I'm Greek, so I thought we're going back to drachma. We're leaving euro. but it was not about that. So it's a very nice acronym because it means grasp. So very interesting for robotics people because drones actually grasp things. So DRACHMA means grasping. So thank you so much for the invitation. So I would like to give a small overview about, in fact, these have been, two different things running in parallel, drone-related technology and wireless communications. And I think there is, very close synergy, and there is a lot to be achieved when you actually bring those two worlds together. So this is what I will try to actually propagate in the next few slides. First of all, I would like to give a little bit, I'm trying to set the scene, let's say, about the penetration of wireless technology and how the wireless technology can be used as a platform where can be utilized by drones delivery as part of one of the applications, but there are many, many different applications. I will go through some of them a bit later on. Of course, it's not, I'm not going to go through all the different applications, but I'm just going to, that's the ground rule about the possible application. So this is the, the number of subscriptions on mobile devices in the world today. So you can see it's really massive, right? So here with Orange, 5G is actually now really taking the baton from 4G technology. LTE was, is slowing down, and now 5G is increasing. We have already 5G deployments in different markets in the world. So this is expected. You see, it's gradually the number of users in 5G networks is expected to increase. At the same time, you can see here also the older technologies like 3G, and normally wideband CDMA is going down, and as well as the traditional, the 2G technology, GSM is also actually now starting to phase out. In fact, we have a sunset of those two technologies. Most mobile network operators over the next 4 years, they will switch off completely these networks, 3G and 4G. In European Commission, in Europe, this will happen until 2025. A little bit same for North America. In UK, it's not set for specific dates for different operators, but EE and Vodafone are actually, over the next few years, they are switching off 3G, definitely. So this is a little bit a picture about, what is happening in terms of the wireless cellular communication world, in terms of penetration of the technology. And I think it's good also to mention a little bit about 5G, what is on offer and how it's different from 4G. What mostly we are having today, or the long-term evolution networks that we are having today, and also touch a little bit about sensing. I know it's not exactly relevant for parcel delivery, but you can think of different, let's say, applications, and also about command and control of the drone. So this time some delays might be, to put that in perspective, might be useful. So to start, we know that tactile applications require single-digit delay in order to actually, for example, do a remote operation. Okay, so normally something like 5 milliseconds. Visual information is about at the range of 30 milliseconds. Okay, so this is actually moving images. And voice communication normally requires something like up to 150 milliseconds, so that to be deemed as a high quality. Otherwise the quality is rapidly decreasing. And what is on offer? This is a comparison between 4G and 5G. 5G is actually deploying right now in different markets, as I have already said. 4G is already being deployed back in 2010. We started, fulfilling, deployments different markets. In terms of latency supported, you can see now we're really squeezing the envelope. 5G, we can reach also less than 10 milliseconds delay. In 4G, this is significantly larger, 20 to 50 milliseconds. And as well as the average rate that we can support Okay, this is the average, not the peak rate. This is average rate. As you can see, increased now at least an order of magnitude. So therefore, we can actually support much more demanding applications. So I think this is good to keep in mind when we discuss about 5G. But I think the important thing about 5G and what is coming is not just, increasing these KPIs. Okay, it's not about more data rate. It's not about less latency. Of course, this is important. I mean, there is a new radio in 5G which can support, higher data rates. We have new frequency bands incorporated in 5G, so we can actually increase data rate, decrease latency. But 5G is about a new ecosystem, and I think this is the important when you try to, bind with different verticals, and I would consider, parcel delivery using drones as a vertical, let's say as a vertical market to cellular networks. And the important here of 5G, as I said, is an ecosystem where we can do some form of network slicing. And I will very briefly mention what does it mean. So this is a figure here from, I use a very well-known figure from GCMA, where you can see that we can now really slice the network, which is something we could not do on 4G. So this is a 5G feature. We can slice the network to fit specific applications. So here is an example about 3 different use case scenarios. Okay, so we have 3 different slices. One is supporting the nominal use case, which is actually supporting end user devices. Okay, so smartphones. Another slice will be about, for example, here, D2D communications, device-to-device communication, such as, for example, automotive devices, but this can be extended to drones. And you can have another slice, which is specially configured to support massive Internet of Things devices. And what is the interesting thing here is that you can actually configure the network, because this network now is fully virtualized, so it is fully softwareized network, to implement the specific needs of your application. And also, the different slices will be running in isolation and completely independent. So this is a very, very big difference of the support of 5G we can have now compared to what is offered on 4G, which was running mostly as a silo, right? So you cannot you don't have this kind of flexibility to bring in different vertical markets, as for example, drones. Now, moving a little bit faster now to drones applications, so UAV applications and drones. I think what I would like to mention is this amalgamation, as I'm saying here, of cellular networks with UAV is actually a key enabler to propel the different applications. So what I have here, I'm just trying to draw here a use case scenario. So as you can see here, I have a drone. It uses this is the trajectory of the drone. I have a user which might be controlling this drone. Okay, the user might also be mobile. Okay, so what can happen here at the scenario, the envisioned scenario here is that we're using the cellular network to provide ubiquitous connectivity to the drone and at the same time control the drone. Okay, so as you can see here, both the drone and the end user can be mobile and can have a completely different mobility characteristics. Observe also at the same time that, as the drone moving from the coverage area of different cells, there will be handover. Okay, the same for the terminal. So therefore, we can actually moving from one cell to another, keep the connectivity, keep receiving and sending information to the drone during the flying time. At the same time, as I mentioned before, with network slicing, what we can do, we can provide edge cloud resources. So in terms of heavy computational tasks that need to be performed from the drone, we can offload this in the edge cloud, which will be supported by 5G, so that we can actually run heavy computational stuff such as, for example, any computer vision algorithm or any other algorithm that we need to run very close to the terminal, so that the latency is very, very small. So this can be configured, a specific slice, in order to support this specific, let's say, application that we have. In addition to that, moving on to my next slide, I have to say that we are not restricted by the coverage area of the terrestrial base station. So here I have an example where we can deploy a relay node to connect this serving, let's say, aerial base station to a terrestrial base station. So that relay node will actually provide connectivity for that serving aerial base station. So therefore, in a sense, we are not restricted by the specific coverage area of the different cells, but we are able to deploy relay nodes, aerial relay nodes, in order to extend the coverage. Also, it is important to mention that here, all this, the salient assumption here is we are using licensed spectrum. This is extremely important because we can use different frequency bands in order to fit the specific needs of the application. For example, we can use lower frequencies so that we can really extend the coverage of the aerial base station to reach further, even including, for example, relay nodes. A good example, for example, going to the LTE frequency bands, which are also part of the 5G, is the so-called bands that have been freed up from the analog TV, the 800 to 900 megahertz, which is very low frequency, which has fantastic characteristics for very long propagation. So we can use this frequency band if we're actually interested in supporting communications, up to, a couple of kilometers. At the same time, we can use millimeter waves, which is also part of 5G, very high frequencies in the range of 28 gigahertz, in order to support very high data rate. Of course, the trade-off here is that the distance will have to decrease. Okay, so we are talking about a very smaller distance. So we have, a wide range of frequencies to choose depending on the specific application. At the same time, as I'm saying here in the last bullet point, this licensed mobile spectrum enables widespread, so it is available in different markets across the world, provides very high quality connectivity because it's licensed, so the interference that we are having is controlled. Okay, it's not like using Wi-Fi at 2.4 gigahertz where we cannot control interference in a sense. It's very hard to control. It's possible to extend, but it's very hard. So, we don't have access to control interference at that unlicensed spectrum band. So this can actually really penalize our application. And as I said, we have a wide range of options using licensed spectrum, which is part of the cellular communications in 5G. So with that in mind, so I have here a slide about the key characteristics and benefits. This is as with respect to ABSs, aerial base stations aided 5G networks. So as I said, we can extend network coverage of terrestrial 5G communication networks. We can provide capacity boost in a very autonomous and dynamic manner. We can provision internet connectivity in the case of a major incident. Okay, so for example, non-usable terrestrial infrastructure, an earthquake or an emergency. Failure of a specific ground node, we can still quickly, accelerate connectivity. And with dynamic relays for backhauling, we can provide unlimited coverage. The benefit is that, due to the versatility of the aerial platform, we can have an autonomous and on-demand network provision. We can lower CapEx compared to fixed wireless infrastructure. We have a controlled network coverage in a dynamic manner. And in the sense of IoT applications, we can extend the lifetime of sensor networks because the lifetime of the sensor network depends on the power it's using to transmit data. So therefore, if the distance between the transmission is decreasing, the power will decrease, or the lifetime of the sensor will be decreasing. So this is also a very, very big benefit of using ABSs. And there are different ways to connect and different use cases. So I have here 3 of them, but they can be, it's a little bit more convoluted. You can actually think of some more based on, joining some of those together. So the first one here is a drone-assisted 5G communications. Okay, so this is actually an extension to what is available from terrestrial infrastructure. Now, the second one is the 5G-assisted drone communication. So therefore, now the drones are becoming end devices, and we can have a ubiquitous control of those devices. And as an extension of that, we can have also drone-to-drone communication. And I have added here, you can see this red dotted here line, which means that in a sense we can have a set of drones that are able to communicate between them and also provide internet connectivity. So these are, different use cases that we can have supported in 5G. Now, on that, there can be a number of scenarios for network optimization of aerial base stations. I'm not going to go to that now too much. I'm going to keep it short, but there are some interesting optimizations that can be done of how you optimize the trajectory and the service time of the drone, as it is a connected cellular drone, in the different use cases. For example, using optimal Hamiltonian paths, or clustering of the different serving drones, and finding, let's say, optimal ways to serve the different IoT devices you have. And you can also optimize how you will deploy your relay nodes in case they need it. Now, in terms of research challenges and knowledge gaps for 5G and beyond aerial platforms, I think for the use case scenario of interest for this in this community, I think here I have an example of an interesting scenario is how you can create optimal chains of drones that support predefined, let's say, quality of service. So you need to deploy a drone, you need to you have a parcel to deliver. There is infrastructure, but it might not be ubiquitous. So in that case, you can deploy, relay nodes, and you need to provide some form of quality of service. So this is a kind of an open-ended problem, how to actually create this an on-demand and dynamic such chain of drones. I think starting from the first bullet point, I think it's important to mention that cellular networks have been designed to support ground users. So normally the antennas is looking towards the ground. However, drones fly quite high. Therefore, some optimization need to be done also on the terrestrial network in order to successfully support drones. So, such as, for example, antenna tilting and control of the lobes of the actual antenna pattern transmission. Furthermore, I think what is looking a little bit ahead for a successful implementation for different services, we really require, as I'm saying here, a tight integration of drones with 5G to create integrated access and backhaul capabilities so that we can provide ubiquitous access and control of the serving drone. So what this can enable a kind of, here I can call it drones as a service, where you can deploy, using cellular infrastructure, you can deploy a very homogeneous way of controlling drones, okay? So with exactly the same code, where you actually control a drone using 5G in Germany, you can use exactly the same, let's say, service to deploy it anywhere in the world. Okay, so I think this is the kind of the success of using 5G in controlling drones. At the same time, using 5G, we can support a number of, services, which can be depending on the application. Especially the one is important here. I'm trying to mention the ultra reliable low latency, which can be useful for specific applications if we want to control the aerial platform. And I mentioned this example of supporting chain of drones. And another example, which is still a kind of an open problem in a sense, is how we can actually create trajectories in order to ensure that we have very good quality coverage, so we can control and command the drone. And this might be, as I'm saying here, you can see this might be different. Okay, this trajectory might be different than the straight line between the start and the end point of traveling, let's say, between the drone, the start and the end point. Okay, so as you can see here, the trajectory can be quite different, but in that trajectory, the blue one, we can have full quality of service and we can have full control of the drone using cellular infrastructure. However, and just to close, I don't want to overrun, just to close with an important note is that, these capabilities might not be everywhere, okay? So here I'm just having the coverage map of GSM technology 2G in Nigeria. This is MTN operator. This is the biggest operator in Nigeria, 40% of the customers using this operator. So this is the 2G coverage map. And now if I switch to 3G and LTE, you can see it's very, very patchy, okay? So in capital, in some main cities in the country. So really, we cannot here use, cellular infrastructure in this part of the world. Where if you can compare, GSM in UK and 3G, 4G, you can see here that really the big difference of the coverage map between, different parts of the world. So this is a big obstacle. But I think this is something we need to keep in mind. Okay, and I think with that, I have concluded my small presentation. Thank you.
Thank you very much for that. I found that very interesting, actually, from the different end of the issues and the problems. One or two of our members have had to dash off because this is a slightly different time from normal. But there's a couple of really good questions, and of course everything is being recorded so we can feed back your answers. To be honest with you, I think there's a few very specific questions, so I may ask the people that asked them to actually pose the question. So Patrick, you've got a very good question about phasing and coverage in different parts of the world.
Yeah, hi there. No, thanks for that presentation. You dwelt a little bit at the beginning on the US, EU and UK, of course, and given our interest in drones are very, very broad, could you say a few words about what the outlook is for the lower and middle income countries for 5G, phasing out of 3, 4G, what the outlook is?
Okay, I think 2G will, GSM networks, I think there are not definite days in different markets. It's mostly, the sunset is more about 3G technology. The reason being is that GSM modems have been used a lot in the energy sector for smart metering. So therefore, it is very ubiquitous, the connectivity. It's a kind of IoT application, and they have been using GSM. So therefore, we will be, I think GSM will be there, even though it's 40 years technology now, started in the early 90s. So because of this penetration in different IoT markets, we will still see GSM around. But in the Western world, there is sunset in this technology as well. But 3G is really accelerating. 3G was not being very successful. So I think a lot of operators are actually switching off their 3G networks. I mean, one of the reasons is also to meet CO2 targets, because they have to show that they have a very energy efficient network. So they are accelerating the switching off. Now, for your question, the specific markets beyond the Europe and let's say North Atlantic, I don't have a specific answer, to be honest. What is the exact time plan for them switching off these networks? What I know is that investment in 5G, it's very glacial, I would say. It's going very slow. it's also due to the, it's a complex, but I think 5G is mostly around the Western world. So I just wanted to flag this, because these capabilities probably will be available in some markets, not everywhere.
Fantastic, thank you for that. I think you've got a brilliant question from, I'm going to be very rude. Can I say HK? Am I allowed to say that?
HK, yeah, HK.
Yeah, cool. I think this is really good because this really is to the point, I think. And of course, the fantastic backgrounds come back, which I'm very pleased.
Yeah, hi, Vassilis. Yeah.
Hello, HK.
Yeah. So thanks for the talk. Yeah, my question that is about the trajectory tracking, because when you talk about the trajectory tracking, in my mind, I think that the simple control policy would be the PID control, and then if it is working in an open space, and then that is not a problem, because there would be some tolerance for the drones to deviate from the planned trajectory. But for example, when the drone is working very close to the destination or doing some inspection, and then that checking is very crucial. Yeah, maybe. So I just want to know what kind of control strategy you are using, so that because you also mentioned about the optimization. Yeah.
Yes. I think, first of all, thank you, HK. Just to mention, Paul, HK is a top control guy. So
fantastic.
I'm not competing with HK, but I think in terms of, in terms of, that's a very good question. But I mean, what the trajectory you are thinking is more of an online trajectory planning. I was talking about an offline optimization where you have some sense of, for example, interference level and connectivity quality of your channel between the different base stations. So therefore, you want to create a trajectory in an offline manner, where you can assure that during that flight time, you have very good connectivity between the different base stations. And for example, optimizing some other metrics, such as, for example, reducing the number of handovers you're going to have. Okay, so it's kind of some auxiliary, let's say, constraints that you can put or you can optimize. But it's not on, I know where you're coming from, but it's not this continuous online, optimization that it's happening in real time. This will be pre-calculated, and will be actually stored for the drone to do this trajectory, to perform this trajectory.
Yeah, I get what you mean. Yeah, so that is you're doing the online planning path planning, and then the next stage is about to use the control strategy to keep track of the trajectory. Yeah,
exactly.
Yeah,
yes, absolutely.
Yeah, so we could have some more discussion about the trajectory issue offline. So when you have time, yeah.
Okay, excellent. Thank you, HK. Yeah, that's a very good question.
HK, I thought that was a really good conversation, and I'm allowed to do this because I'm the chair. We're a little bit over time. Am I understanding you correctly? Because one of the things around various user cases is that often you have dense areas with lots of communications, lots of coverage, and areas with nothing. But as long as you can get between the two dense areas, the control bit is when you land and take off. If you can almost aim and fly and have some completely offline flight to go from one node to another, because often you have a clinic somewhere, another clinic, people can get to those two clinics, but moving the very time dependent and high value medicine or organ or test between those two nodes, that's where the advantage is. So, you can go a few kilometers off if there's some onboard, collision evasion type of kit on there, and quite a lot of that exists. So what are your feelings about that? Can we have parts of the flight that are less controlled but can be gathered up once you go from an urban area to another urban area, perhaps?
Yeah, so in my opinion, I think that it really depends on the mode of the working, as well as the enrollment, because I think that if it is just between two nodes, if there's only one single drone, that is nothing to do with the formation control, for example, multi drones working together to carry one thing, and then the trajectory, that would be very important. For example, if that is a very windy situation, maybe one drone, it is going to crash with another. So the I mean, the uncertainty tolerance as well as the trajectory tracking, in that case, that would be very crucial. Yeah, but if it is just one drone working in the suburban area, and that I don't think that it would be an issue. But because when we consider some situation during the landing, during the narrow space, and that this kind of issue will play an important role. So I think that the control trajectory, the control policy will not be just one single policy. For example, a linear controller, maybe there would be some switching mode. Yeah, in some complicated enrollment, some more sophisticated control policy has to be used. Yeah, so that is so that is something in my mind about this.
That's a really interesting point. And I guess as the sector expands, at the start of it, there's a lot more space. As the sector expands, there'll be more drones, so you have to have more control.
And I think the real problem here is, I think, as I mentioned, this antenna, of the cellular networks looking downwards rather than upwards, right? Because normally, we keep our mobile phones up to 1.5 meters. So you have to redesign some part of your network. I mean, not hardware, but it's more software, so that you can keep track of the drones because they fly quite high. So this is completely different from pedestrian users with normally, mobile users. So there is some interesting optimization that can take place.
Now, I think this is a fantastic conversation, and I'd love to spend all afternoon at it, but we've got various things. But I have got another question. Is it Emmanuel? Have I got that, Emmanuel?
Yeah. Correct.
Yep.
Thank you. Thank you very much. Great talk. Also, I thought I should raise my hand because I also have a comment on this exact point you were discussing now about the trajectory optimization or generation. So are you basing the control on a model? Is it a linear model or is it not model based at all?
Okay, so for the work that we have done, for the work that we have done so far, we consider a number of nodes that we need to visit. Okay, so and there is a number of drones that fly and a number of users. So you're trying to find a trajectory, which is a Hamiltonian path, which is already an NP-hard problem, and we translate that to a MILP program. Okay, so we formulated this and we try to solve this with different ways of solving this problem for small to medium sizes, of course, because it's an NP-hard problem. But this is the approach. This is a little bit different from what HK was mentioning. Okay, so this is an integer linear program, mixed integer linear program that we formulate, and in order to find optimal, let's say, Hamiltonian paths when you have to, visit a number of nodes. So this is what we have done.
I see. Thank you. So basically, I think in your optimization, do you account for the model of the robot? So all the constraints arising from the fact that, let's say, the drone has a floating base, so its dynamics can be quite complicated, actually. I mean, you don't know whether a specific control input will yield a specific output because there's no direct relation. So is this something that's taken into account in the optimization?
We have considered very few of them. Such as, for example, we haven't considered acceleration. The acceleration we consider energy consumption. We consider energy consumption of hovering, different energy consumption for flying, for different speeds, right? But we created trajectories, and we assume later on, for example, HK could actually say, no, you have to follow this trajectory. We are telling the drone you have to go from A to B. How you keep that track, then it's a different problem.
Yeah, exactly. Yeah. So I was thinking, because in the optimization of the trajectory, I mean, do you just consider that you're moving from one point to the next? So, I mean, the drone is considered to just be a point flying in the sky, instead of, let's say, its orientation as well as its position, maybe going off course and having to be corrected during.
Because you cannot model this in an integer linear program. So what you can model, in an integer linear program is, the actual, lines that has to follow. I mean, you can do a little bit more exotic things that you don't need to reach the specific, node, because you have wireless transmission. So you can actually get the information. You can get the information from the sensor as you fly, right? Instead of hovering. So you can do this, but you cannot do something more than that.
Excellent. Thank you for that question. We've lost you there a bit, Emmanuel. You've turned your. I think the question's been answered. If we can,
hopefully.
if that's okay. Brilliant. So I think we're about there. I think two very different but connected talks. I thought, thank you, Vasilis. That was fantastic. Looking at some of the control issues and some of the coverage concerns as well. That was very good. And then the recording of the data, and the sharing of it as well. And I think some of those databases for the engineers to look at, frequency of trips, that kind of stuff, really vitally important. So thank you both. I think I've got, is Emmanuel come back? I don't know. Is this, hold on, who's this? Somebody's come up. Oh, thank you very much. Brilliant. Earphones run out of battery. Don't worry. we also,
Thank you,
we're at the top end of technology. But the batteries for drones is the key problem as well. So there we go. So at that point, I'm going to say thank you very much. I'm going to stop recording because I always forget to do that. That's good. Will that work? Hold on.